Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of equations and inequalities. This is standard 7.11a in the great state of Texas, and we are using item number 20 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got Walter and Brian each having a CD collection. So I'm just going to visualize this real quick. Here's Walter. Here's Brian. So they've got CDs. So the number of CDs in Walter's collection can be represented by X. We really don't know what that is. I'm just going to put X. And then the number of CDs in Brian's collection is 3 times the number in Walter's collection. So if Walter's got X, I'm just going to put, there we go, 3 times as big. And then the total number of CDs is in both collections is 144. And so I'm looking for X, the number of CDs in Walter's collection. Well, let's see if we can figure out how we can turn this into an equation. So everything all together makes 144. So another way to write this, let's see if I can start trying to write this as a linear equation here, is I've got X, we're adding it together, plus, look at how many X's I've got right here, right? I could say X plus X plus X, but you can also say just 3X. You can multiply this simple array, right? If it's a 3 by 1 array of, I've got 3 X's, and add those together, 144. Now I need to combine these two terms right here, X plus 3X, and sometimes this gets a bit tricky. We're not sure how to combine this. That's why this picture is actually very helpful right over here. Simply count. How many X's do we have? 1, 2, 3, 4, which means these two terms combine into 4X. So you can actually add X's together, and all that does is that just changes the number right in front of it, and that changes that coefficient, and it just ticks up 1 every single X you add. And if we wanted to test this out, right, we could easily test it out by just making X equal 10, right? So if we wanted to make sure that that 4X is good, we can say X is 10. So that's 10 times 3 times 10 would be 10, there we go, plus 30, so that's going to be 40. And we know that 4X equals 4 times 10. Yeah, that works, equals 40. So if you're not sure if we could do it like this, just plug in a really simple number and just make sure it works. So now we've got 4X equals 144. It's pretty simple. We need to isolate this variable. We're always going to do that with order of operations in reverse, because these are your weakest operations from the bottom. We don't have any addition subtraction, but we do have this multiplication. It's 4 times X. So we simply use the inverse operation of multiplication. We divide both sides by 4. And so now I've just got X equals 144 over 4. It's just going to be a little bit of long division. Not sure what that is. I know my 4's, but I don't know them that big. So 4 goes into 14 3 times. So that's going to be 12. Look at that nice even number, 24. 4 goes into 24 6 times. So there we go. That makes sense. So it's going to be 36. So X is going to equal 36. And that's, if we wanted to, right, we could put that X right there. We could put 3 X's right here, 36, 36, 36. Or we could just multiply that 36 times 3 to get what Brian has. But we're looking for X here, 36. That's J.